In 3.6, we're going to kind of take a break from some of the other stuff we've been doing with radicals and rationals and solving and methods of polynomials and zeros, etc. And we're going to look at variation. There are three types of variation we're going to look at. The first of them is direct variation. With direct variation, it says as the input increase, the outputs increase. And so with this, what's happening is the two quantities are directly related, meaning if one goes up, the other goes up. If one goes down, the other goes down. So a general note of direct variation, if x and y relate by equation of the form y equals kx to the n, then we say the relationship is direct variation, or it varies directly. Also, we pick up this word called the constant of variation, k. So the key word to remember when you're doing direct variation is you are multiplying. When you're multiplying, you'll be multiplying that k times your other quantity. So kind of just steps, simple steps, identify your x and y, determine your constant variation. So we're going to find our k. We're going to write an equation and then find an unknown. So really an example is best to kind of understand what's going on with these. The quantity y varies directly with the cube of x. When you see this word varies directly, I want you to think multiply. And you're going to write your equation or your template of your equation very straightforward. Y equals k, you'll have to include the cube of x, so x cubed. So this right here is our template of what we're going to use for this problem. Next, step 2, we're going to find our k. So we're going to use the first piece of information to find k. So I say 25 is equal to k times 2 cubed. I'll say 25 is equal to 8k and divide both sides by 8. So step 2, I found k to be 25 over 8. And don't stress if you get fractions. Remember, in middle school, everything was 2s and 4s and 1. But here we can have fractions or really large numbers. So don't let that stress you out. After you find your constant variation, next you're going to write an equation for the relationship. We're just going to plug k back into this template we created. So we'll say y is equal to 25 over 8 x cubed. Lastly, we're going to find the unknown. We want to figure out when x is 6. So I just take my equation I have given, 25 over 8 times 6 cubed, and then I solve that out. Using my calculator, this gives me 675. So in grading a problem such as this, these are things I'm looking for. Your template, your constant, your new equation with your k filled in, and your final answer. Let's look at number 2 to kind of reaffirm this. The quantity y varies directly with the square of y. So the fact that you saw varies directly, I want you to think multiply. Then start with what it's going in. This is a typo. This should have been an x. The quantity y is equal to k directly, so I'm going to multiply the square of x. I'm going to say x squared. So there is my template. I'm going to use the next piece of information to find my k. So 24 equal to k times 3 squared. So 24 is equal to k times 9, and then divide. So k would be equal to 24 over 9. Next point I'm finding. Then I'm going to use that to plug in my template to find my new equation. So 24 over 9 x squared, and really 24 over 9, that reduces to 8 over 3. So that's really the best k. So there's my equation. Then I'm going to find my unknown. So I'm going to plug in 4. Plugging in 4 squared, using my calculator, this gives me 128 over 3. So it's about 42 2/3, but don't ever put 42.6 repeating. Go ahead and use the simple reduced improper fraction. So you can see in finding direct variation, it's not a ton of work. We've done longer problems in this unit, but you want to make sure you're understanding what is given, how you can use it, and finally answering the problem. So direct variation is one type of variation. The other type of variation is inverse variation. Whereas when you saw direct variation, you thought multiply. With inverse variation, I want you to think divide. And it says as the input increases, the output would decrease or vice versa. So these items are going in opposite direction. Now in solving this out, everything is as usual. You might see words like varies inversely, inversely proportional, inverse variation, or it might just tell you a situation and you have to use with that situation and go, okay, one's going up and one's going down. So this is going to be inverse. Not every problem is just going to be a cookie cutter problem of keyword, work it out. Some of them you're going to have to think about it and think, are the two quantities doing the same thing? Then direct variation. Or are they doing an inverse variation? So look at this one, same process, same steps. A tourist plans to drive 100 miles. Find a formula for the time the trip will take as a function of the speed the tourist drives. Excuse me. So in order to work this, I've got to go off some previous knowledge. I know that from the past that distance is equal to rate times time. If you're going 70 miles per hour for 3 hours, you can figure out the distance that you went. So for this one, I'm going to use the information they gave me. He plans to drive 100 miles, so that would be 100 equal to rate times time. Find a formula for time, so I'm going to solve for time. So I get T equal to 100 over R. You'll notice that this one, it was divisions. There's my inverse variation, and 100 is my constant of variation. So with this one, not much arithmetic to do, but a lot of analysis that we need to do in kind of order to figure that one out. So again, I didn't want to do every problem cookie cutter of keyword, find the template equation, but I wanted to do one that just relates into this concept, but didn't really have as much arithmetic to it. For the next one, it says a quantity y varies inversely with the square of x. So again, inversely, I want you to think divide. So this would be y is equal to k over x squared. So there's my template. I'm going to use the next information to find my k. So it says when y is 8 and x is 3. So it gives me 8 equal to k over 9. And then multiply both sides by 9 to solve for k. So it gives me k to be 72. Again, don't go back to middle school and think, okay, everything has to be 2s and 4s. 72 is okay. Fractions are okay. So go back and plug that in here to get your equation. So y is equal to 72 over x squared. That's my equation. Lastly, I'm going to find my unknown. Plug in 4 for x. So it'll be 72 over 4 squared, which is 72 over 16, which reduces to 4.5. So again, another type of variation, when you see direct, multiply, inverse, divide. And you'll see a few of these on your next exam. Lastly is joint variation. Joint variation puts everything together. So mixing up some of those variations and having more than 2 variables. So let's just jump into the examples. A quantity x varies directly with the square of y. So that means x is equal to k, the square of y. And inversely, so I'm going to think divide with the cube root of z. So divide by the cube root of z. So there's my template. So I'm going to use the first piece of information to find my k. So we've got 6 equal to k, 2 squared over the square root of 8. Excuse me, cube root. That was the cube root of 8. Don't let that freak you out. Just go slowly. So 2 squared is 4. The cube root of 8, use your calculator, is 2. 4 over 2 is 2. And divide. So k is equal to 3. Plug that back into your equation. X equals 3y squared over the cube root of z. So there's my equation. Now find my unknown. So it gives me x equal to 3 times 1 squared over the cube root of 27. So that'd be 3 over 3. Cube root of 27 is 3. So just 1. So there's you a nice middle school answer of 1. But notice with this one, the only thing different than the previous 2 pages was just putting it all together. Go slow, create your equation. We'll do one more. X varies directly with the square of y, so that means x is equal to k, the square of y, and inversely with z, so we're thinking divide. So there's my template. Use the first piece of information to find your k. 40 is equal to k times 4 squared over 2. So it gives me 40 equal to, let's see, 16k over 2. So 40 is equal to 8k, and divide. So k is 5. Plug that back into your equation. X is equal to 5 y squared over z. Now find our new unknown. So that's equal to 5 times 10 squared over 25. So let's see, 500 over 25. So 20. So again, variation is not super long and intensive, but it's very analytical. So make sure you understand what you're given, what you're working with, and find your pieces along the way. Again, contact me if you have any questions in regards to this section.